Welcome back to Written Theory 4. We're continuing our discussion of serialism today, just touching on some different properties that rows of notes can have, especially in 12-tone music. Let's just take a look at some different rows today and see what all types of interesting things they have for us here. So the first row we're going to take a look at here. This is a row. This is the tone row from Berg's lyric suite. And if you'll notice the different intervals that exist between the different pitches here, you can see I've got one interval class 1, it goes up 11. Here I've got one that goes up a half step. We've got one that goes up 8 half steps. We've got one that goes up 4 half steps. Up 8, of course, is the same as down 4. Up 9, up 3. Up 10, up 2. And of course, the tritone is self-inverting. That's up 7 half steps. That's up 5 half steps. And so the row that Berg has chosen to use here actually has all of the different possible intervals present in it. And so we call it an all-interval row. And you can tell this because it has one tritone, and it has a positive and negative version of each of the other interval classes, 1 through 5. And so there's all sorts of interesting things you can do with that, because you're never going to hear the same interval class twice in a row. And the interval classes have been equalized out in the same way that pitches have, so even the intervals are on an even footing. Our next one here, we're looking at Webern now, from his Opus 24. This is a neat little row, because you can see here, looking here, that if you group it into 3 notes, sets of 3 notes, or trichords, they all have the same intervals between them. They're all, down a half step, and up 4 half steps is the first one. A nice little 014 there. That's one of Schoenberg's favorite set classes, of course. And the letters SCH form an 014 trichord. And you can see that the second trichord is a retrograde inversion of the original one, transposed down accordingly, but the intervals are, backwards of that. If you compare the next 3 notes, 8, 4, 5, that's the retrograde. If you look at the intervals going backwards, 2, 10, 11 would be down 4 half steps and up 1 half step. Well, 8 to 4 to 5 is down 4 half steps and up 1. So it's a retrograde of the original trichord, transposed again. And then the last 3 pitches, you can see our original 3 pitches, we went down a half step, up 4 half steps. These 3 pitches go up a half step and down 4 half steps, so they're an inversion. And of course, if you took the inversion backwards, you'll be able to see that the retrograde inversion is there. So Webern has created a row that features, 4014 trichords, set up in such a way that he has a prime form, a retrograde form, an inversion form, and a retrograde inversion form of the trichord transposed onto different pitch levels. And so that offers some interesting possibilities for composing a piece of music using those 3 notes at a time. Another interesting relationship with rows. Let's go ahead and pull up here. This is our Opus 25 that we took a look at last week. Our last video wasn't necessarily last week, depending on when you're watching this. It is for the sophomores. But you can see here we've got a P4 and a P10 form of this row. And I've highlighted, you can see the 7 and the 1, and the 1 and the 7 I've highlighted those in red. The 6 and the 3 I've put in purple. The 0 and 9 I've put in green, and the 8 and the 2 I've put in blue. And both of these row forms have these show up. And so this is what we refer to as invariance. The fact that those pitches there are in the same order, same grouping of notes, and you can use those to make motives, as we saw last week that Schoenberg deliberately used, especially that G to D flat, the 7-1, was in fact a motive that he used often in that prelude excerpt that we looked at in the last video. Webern, again, one-ups this a little bit. This is from his Opus 28, and this is the prime 7 and the prime 3, the P7 and P3 rows. And notice that here 7698 shows up as 8967 in the middle of the next row. 0, 1, 10, 11 shows up as 11, 10, 1, 0, backwards there. And 3, 2, 5, 4 stays in the same order. So this is a particularly clever row in that we have tetrachordal invariance. And Webern is able to play with groups of 4 notes here, retrogrades of each other, or same version of each other, and you can draw upon that as a compositional possibility to pull out motivic similarities between these different rows. And so that's your invariance, and it's really neat when you build a matrix to kind of do a little word search type in the matrix and go hunting for invariance in the matrix here. Trying to position my head so that I'm not picking up my light in my eyes too much and that you can still see me talking here. So we're working with the technology, doing what we can. All right. The last row property I want to talk to you about today is what's called hexachordal combinatoriality. It's kind of like a special development of invariance, if you will. What I have here, there we go. I can see my mouth again, for what that's worth. But what we have here is, if you look down at that, I've got the prime, the P10, and the I3 rows of Schoenberg's Opus 33A piano piece. And so what you may notice is that the first hexachord of P10 has the pitches 10, 5, 0, 11, 9, 6. They're rearranged, but they're the same 6 pitches as the last hexachord, the last 6 notes of I3, 0, 10, 6, 5, 11, 9. And what this means then is that if I pair, the Schoenberg pairs P10 and accompanies it with I3, not only do we have the aggregate, all 12 pitches going horizontally across P10, and I3 has all 12 pitches, but combining the 2 rows together, if we split this up with hexachords, I have yet another version of the aggregate. So it's another way of having all 12 pitches show up without necessarily being in the same order of the row. And let's take a look at a piece of music that uses this invariant. Look at an excerpt from the Opus 33A. There we go. And you can see I've row counted. The top line has our P10, pitch number 1 on the B flat there, 2, 3. I'm doing the counting from the top to the bottom note by the 2/3. That's the top note / bottom note. Bottom note's moving, so 2, 4, 6, 5, 2, 4, 2, 3. He kind of goes back and forth, between the notes. Serialism doesn't mean you have to use the notes in order and never come back to them ever again. It just means that you're being deliberate about the choices of the notes. There is still room for, some musical choices, compositional choices by the composer of the music. And then after the first couple of measures, you see in the bottom I3 is going note 1, 2, 1, 2, 3, 4, 5, 5, 6, while the top one's resting. After those 2.5 measures, where they're working with the first hexachord of both row forms, we come back in, we've got P10 still on the top, I3 still on the bottom. But you can see now we're working with the notes 7, 8, 9, 10, back and forth between those, and then back and forth between 9 and 10 and 11 and 12. While on the bottom, 7, 8, 8, 7, 8, 9, 10, 7, 8, 9, 10, 10, 11, 12. And so we'll take a quick listen to this and hear the effect of that hexachordal combinatoriality. Yeah, so those are some interesting features of row forms. We looked at invariance, we looked at all interval hexachords. We looked at the Webern example is what we call derived row, and that's where you derive a row from doing interesting things to subsets of notes. And so he took the 014 trichord, and by combining it with the right transpositions of the P, R, R, I, and I forms, he created a 12-tone row. So he derived that row from his 014 trichords there. So derived row. So we've seen all interval rows, we've seen derived rows, we've seen pairs of rows that have invariants in them, and pairs of rows that feature hexachordal combinatoriality. And so, we always talk about the two most interesting questions when we're in music theory are what is it and what does it mean? Identifying the rows, constructing the matrix, row counting, that tells us what's there. But then our next step, we want to analyze the rows and try to figure out why the composer chose the row forms that he did. Why did he choose with the row that he did, for that matter? What interesting features are there of the row? And that starts answering a little bit more of the why questions. Why did the composer use this row? Why did he put the notes in this order? And that's the fun part of analyzing 12-tone music. So hopefully this was helpful.